Okay, welcome to week 12, part one. Let's take a look at number one. Okay, so this one is really tempting just to grab your phone, photo math it, but it's very, very, very important that you get good at these algebraic steps. This is not the last math class you're ever going to take, and we need to practice these algebraic steps. So, what am I going to do first? My first step is I'm going to distribute the 3. So we have negative 12 minus 12x is equal to negative 72. Okay, so now I'm going to draw a line down my equal sign. I'm going to isolate my variable. So I'm going to get rid of the negative 12 by adding 12 to both sides. So those cancel. We have negative 12x, negative 72 plus 12. That is okay to use a calculator on. So we have negative 60 divide by negative 12. X is equal to positive 5. Number 4. Now, what am I going to do before I distribute that 3? And, okay, first of all, do I add those together? Let's see. Please excuse my dear Aunt Sally. This is multiplication. This is addition. Is it okay for me to add before I multiply? No. Okay. So since I can't add them together, I'm going to get rid of that 4. So I'm going to subtract 4 from both sides. So I'm going to go ahead and distribute as well. 3 plus 12a is equal to 51. Okay, now I am isolating my variable. Yeah, it's the most important term in the equation. So I'm going to subtract 3 from both sides. 12a is equal to 48. Okay, one more step in isolating the variable. This 12a, there's nothing in between, there's an empty space, so that makes it implied multiplication. The opposite of multiplying by 12 is dividing by 12. So a equals 4. Now, this is where I see people have the most trouble. This category of solving has X's on both sides of the equal sign. Okay, so what am I going to do next? Think ahead of me. I'm going to distribute the negative 8. So I'm going to have negative 8 minus 56x is equal to negative 8 minus 3x. Okay, so let's move all of our x's to this side. Now, negative 56 is technically not bigger than negative 3 because they're negatives, and we want fewer negatives, not more. But we're going to move all our x's to the left and all our numbers to the right. So how can I get rid of negative 8? Add 8 to both sides. Okay, those cancel. Negative 56x. Those cancel is equal to negative 3x. Now, I have not moved all my x's to the same side. They're not together yet. So I'm going to add 3x. You must have all your x's together on the same side. So now I'm down to 0. So negative 53x is equal to 0. One more step. Do I add 53 or do I divide? Divide by negative 53. Can I have a 0 on top of a fraction? Yes. 0 divided by negative 53 is 0. Number 4. Okay, so we're going to learn a new trick to multiply these two binomials together. Okay, now we know that we can use a box. Okay, and then we're going to combine like terms. Now, are you ready for a shortcut? So if we put the 3 and the 5 on the sides of my diamond. Now, this is why we've been practicing the diamond. How do I get the top number? You multiply to get the top. How do we get the bottom number? We add to get the bottom. Okay? So this is what happens. This is m squared. You add to get the middle term plus 8m. You multiply to get the end. Now, can you see that I would get the same thing here? Combine like terms, m squared plus 8m plus 15. You'd get the same thing. Okay, so we will talk more about those in the future. Now, notice that the coefficient is 1. Okay, so I'm going to call this an easy diamond problem. So the coefficients of the variables, all the coefficients are 1. Okay, so you could do an easy diamond shortcut. Can I do the shortcut on this one? No, because there is a coefficient in front of the variable other than 1. So what does this mean? This means 7x plus 2 times itself. So let's make a diamond. 7x plus 2, 7x plus 2, 49x squared, 14x, 14x, and 4. Combine like terms, and what do you get? 49x squared. Now, when I combine like terms, the exponent doesn't change. I'm just combining 28x plus 4. Okay, let's review number 6. Now, how do I solve a quadratic? First step is isolate the quadratic, but there's nothing there. Okay, second step, the inverse operation of x squared is square root. So I'm going to take the square root of both sides, and that gives me 2 answers. So I have p plus 2. What's the square root of 16? 4. And p plus 2 equals -4. Okay, solve these equations. P is equal to -6 and positive 2. Okay, thank you for watching. We're not going to practice this one. You can skip, okay, and write skip, and that's how I know you actually watched the video. So the first thing we do, the first thing we get rid of, we know that by the order of operations, multiply is stronger, a stronger bond than add. So we're going to subtract 10. We're going to get rid of the easy things first. So 2p minus 8 squared is equal to 72. Now I can get rid of this. The opposite of multiply is divide. P minus 8 squared is equal to 72 divided by 2 is 36. Okay, the opposite of squared is square root, and it splits it into the plus and the minus. So we have p minus 8 equals, what's the square root of 36? We have positive 6 and negative 6. It doesn't matter which one you put left and which one you put right, but doing negative on the left and positive on the right will help you when you eventually have to graph these. Okay, so isolate your variable, get rid of the 8 by adding. So P is equal to positive 2 plus 8, and you get 14. Okay, we're going to take the square root. Now, what is the square root of 5 squared? Yeah, that is the square root of 25, which is 5. Everyone agree? What is the square root of 6 squared? That is the square root of 36, which is 6. 7 squared is 49. Square root of 49 is 7. Notice that squaring goes up, square rooting goes back down. They're inverse operations. It's like wrapping a present, unwrapping a present. Okay, that's what the inverse does. It undoes the operation. Okay, so what if I get rid of these? Notice that square root cancels squared and the 7 comes out. Square root cancels squared, the 6 comes out. Square root cancels squared, the 5 comes out. The 5 comes out. So now, what is the square root of x squared? The square root is going to cancel the squared, and the x is going to come out. What is the square root of v squared? The square root cancels the squared, and the v comes out. Okay, so I'm going to split this into 64 and v squared. So square root of 64, you can use the calculator, is 8. Square root of v squared is v. Okay, number 10. 80 is not a perfect square. So I need to find the factors of 80 so I could have the biggest perfect square and the leftovers. So let's write out the factors of 80. Okay, so there's our factors of 80. Now I'm looking for the biggest perfect square, which is 16. So I have the biggest perfect square, the leftovers. Now I know that the square root of b squared is b, correct? What do we think the square root of b to the fourth is? Let's see. That is b squared b squared. Yeah, you add the exponents, which is the square root of b squared is b, right? And another b is b squared. So square root of b to the fourth. Basically, I'm dividing by 2. Square root of 16 is 4. Leftovers stay in. Square root of b squared, square root of b to the fourth is b squared. Let's move our square root to the right. 4b squared, square root 5. All right, thank you for joining me.